120. And I want you guys to evaluate the piecewise function, then graph it. Let me let this person in. Betsy. So I'm going to write out the function f of x equals 2x plus 1 and then negative 2x plus 3. It's the top function if x's are less than 1, and it's the bottom function if x's are bigger than or equal to 1. So first we're evaluating, so we're finding f of negative 2, f of 6, and f of 1. Let me move this thing. And I think I heard somebody coming in. Math. Okay. All right, so we have these 3 values that we're looking for. So we're going to solve for those first, and then we'll go ahead and graph. So let's see, Peyton, your little thing is up on my screen. So why don't you answer? You can pick any one of these 3 to evaluate.
I guess F6, F with the 6 in parentheses.
Yeah, f of 6. Yeah. So is 6 going to be smaller than 1 or bigger than or equal to 1?
Bigger than, I guess.
Yeah, exactly. So we're going to use this function. So can you tell me what to write if I'm taking the 6 and I'm replacing the x with it?
Okay, put negative 2 parentheses 6 3
Plus 3. Perfect. Good job. And then what is negative 2 times 6?
It's negative 12.
Perfect. And then if I add 3 to that, what should I get?
You will get, dang, what is it? It's like, it's negative, negative 9 or 10.
Good. Yeah, 9. Very
negative
good.
9.
Yeah, so you can think of 3. If you take 2 away from the 12, then it's going to be 10.
Yeah, I wasn't counting on my fingers.
Good job. Excellent. All right, so now I need somebody to do f of negative 2 and somebody to do f of 1. Let's just see who is up. Delamar.
Yes.
Do one of these?
Yeah, I'll do negative 2.
Okay. So which domain is negative 2 in?
It's less than 1.
Very good. And so we're going to sub it into that function. Can you tell me what it would look like?
2 parentheses negative 2 plus 1.
Yes, very good. And what do I get when I solve that?
Negative 3.
Good. So this is negative 4 plus 1, which gives me negative 3. Excellent. All right, and then let's see who's next. Brandy, can you do the very last one for me, please?
Yeah, it's greater than or equal to 1. So
very good.
You put negative 2 parentheses 1 plus 3, and you get 1.
Very good. Negative 2 plus 3 is 1. Perfect. All right, that was great. I'm going to go ahead and do our graph over here. Okay. When we graph this, we know that we need to have, we need to show this like transition point between the 2 functions. So we definitely need to have the 1 labeled on our graph because that's where we transition from one function to another. Okay. I'm going to make a quick table for each of the functions. Okay. For the first one, we want values less than 1, but I'm going to put 1 on there because we always want to include it. I'm just going to note that we're going to have an open dot. I want values less than 1, so 0 and negative 1 are less than 1, so those would work. Then for the second one, I want to include 1, so I'm going to have a closed dot there. And I want values bigger, so I'm going to do 2 and 3. Okay, so f of 1 we found was 1, so we would have that there. We do need to find out for this one what f what that value would be because we want to put an open circle at that value. So 2 times 1 is 1 plus 1 is 2, so we should get a 2 there. We'll go ahead and finish it out with this one. So this table was for the 2x plus 1 function, and this table was from the negative 2 plus 3 function. If I sub 0 in here, I get 1, and negative 1 would give me negative 1. For this other function, I get negative 4 plus 3, which is negative 1. And then negative 6 plus 3, which is negative 3. So then I can plot these. I know I should have an open circle at 1, 2. I know I should have a closed circle at 1, 1. Okay, those are the first 2 points on each of my tables. And then I have a point at 2, negative 1, and a point at 3, negative 3. Okay, so I should have a line coming down kind of like that. Then for my other table, I know I have a point at 0, 1, and a point at negative 1, negative 1. So I would have a line going down like that. You get something like that. It doesn't need to be perfect. Mine is definitely not perfect. And I sped through that example, so that's okay. We can go over more graphing stuff if you guys like on our little review. What questions do you guys have now that I've sped through a problem unnecessarily fast? Okay, there are no questions. I posted this little half sheet on Canvas. It was originally like a homework sheet, just like a homework half sheet that we did. But I am repurposing it as a review for you guys. Okay. So we are going to be graphing the following piecewise functions and finding their given values. So I'm going to find the given values here, and I'll probably make a little graph up at the top of each one of these. So we're going to work through this, all right? And we can also talk about, there were some issues with you guys when we had things like, maybe it would say find or evaluate. -3 times f of 1 minus 4 times f of -5, maybe plus f of 0. If I gave you guys something like that, which I did on the last homework and classwork assignments, you guys kind of struggle with that, so we can go through those together as well. I'm going to do that on another sheet of paper because I don't want to cram everything in and make it unorganized. So I'll do that on another sheet of paper when we get to it, but we will go through problems like that. Okay, so first we have this piecewise function with 3 pieces, okay, 3 domains. And so when we evaluate, our first question should be, where is this x value? Is this x value in this domain, or that domain? Okay, so reach for my other classes possible stuff. Let's see, Heaven. For f of -5, which domain, which of these 3 domains is it going to be in?
Can you repeat the question?
Yeah. We have our x value as -5. Which of these 3 inequalities is -5 going to be included in? So is it like between -6 and -1, between -1 and +1, or is it bigger than -1 or bigger than positive?
The first one, -6.
Yeah.
Okay.
So it's going to be in this domain. That means that we're going to stick it in this function. So what is the absolute value of -5?
5.
And we're done. Okay, that's all it's asking. Let's see. Who's next on the list? Destiny, are you there? Destiny? Okay, let's see. Juan, are you there?
Yeah, hello. I'm sorry, I
Okay,
didn't
so -8.
hear.
Is there a domain here that -8 fits inside of?
-6 greater than or equal to?
So this is saying -6 is less than or equal to x, which is less than -1. So if I drew that out on a number line, and -6 and -1,
No,
its
that's
values here. So where is -8 on that number line?
farther than 6.
Huh?
On the left of 6?
Yeah, it's to the left of -6. So is -8 in any of these?
The middle one?
Don't guess, just is it? We said it was not in this one. Is it between -1 and 1?
I mean, it has to be, but I don't know which one it is.
Why does it have to be? It's not between -1 and 1, and it's not bigger than 1. So this solution does not exist on this graph.
Exactly.
That's all you had to do.
That's what I meant to say. That's why I was testing you.
Oh, okay. All right. Good job. All right. Thank you, Juan, for the answer to my trick question. Roxy, can you do f of +1 for me?
Is it -1 is less than or equal to x less than 1?
So that's a good thought because it's got 1 here, but what symbol's right there?
Oh, less than?
Yeah, so does it include it?
No.
Does it include it in this one either?
Yeah. Yes. Oh.
This is kind of similar. It skips 1. So it does not exist. So this is not a continuous function because it skips a point along the line. Okay, thank you, Roxy. And the very last one is f of 0, and this one is not a trick question. Asai, can you answer?
Yeah, it's the second one.
Yeah, so f of 0 is between -1 and 1. So I'm going to stick it inside of this function. What would that look like, Asai?
0 squared.
Yeah, so I'm taking 0 and I'm squaring it. What do I get?
0.
Yep, perfect. Okay, so these are the solutions to each of these things that they asked you to evaluate. What questions do you guys have on this before I start graphing it and we work on more complicated evaluation questions? Does everybody understand like why these two do not exist? How we got these two? I'm hoping so. Okay, so I'm gonna make a little bit of extra space so that we can try to graph this. So when we graph piecewise functions, it's kind of nice to have a table for each of our domains, just like we did in our notes the last class. So I'm gonna make a little table for each of our domains. X and Y values.